Swayam Prabha. Digital India. Educated India.
So, we were discussing dummy variable model in our last class, right? And we have discussed two types of actually three types of dummy variable models. ANOVA model wherein we have only dummy variable or qualitative variable as explanatory variable. Then in the second case we have also introduced a quantitative variable as well in the right hand side, and we call that model as ANCOVA model. Then in that ANCOVA model itself we got another case which was the third case of our discussion, where we were interacting the dummy variable with the quantitative variable. So, we will quickly recap all those models once again before we start about our new models of dummy variable in today's discussion. So, the first case was this is the first case what we are discussing. This is wage of the ith individual was alpha plus beta 1 di plus ui, and this model we said that ANOVA model, since we have only dummy variable model in the right hand side. This model is not it's very it's a rare case wherein we have only qualitative variable in the right hand side, rather we have qualitative and a mix of qualitative and quantitative variables. Anyway, for simplicity's sake we have assumed this is our first case. And how was our di defined? Di was equals to 1 if male and 0 if female. These are the two cases, two categories of the gender variable that we were discussing. And then we said that when you do not have any other quantitative variable in the right hand side, the intercept, what was the interpretation of the intercept? Alpha. Alpha basically indicates the mean salary or mean wage of the base category and what is the base category here? Here it is the base category is female, since we have not introduced any dummy for the female category, right. And then what does beta 1 indicate? Beta 1 basically indicate the differential intercept. So, that means we can say that beta 1 indicates on an average this is first we will say that this is differential intercept, So, that means if alpha denotes the intercept of the base category and beta 1 indicates differential intercept. So, you can easily understand that means beta 1 indicates on an average male's salary or wage is beta 1 times beta 1 amount higher than the female category, very easy. Okay. So, alpha is the intercept for the female category or the base category, and alpha plus beta 1 is the intercept for the male category. That means beta 1 indicates the differential intercept. Okay. So, that means we can say that the interpretation of beta 1 is differential intercept, or alternatively you can say that on an average male workers male workers wage is beta 1 amount higher than their female counterpart. Female counterpart. Female counterpart. This is the interpretation. And what was the second case we were discussing? Second case, we introduced one quantitative variable also, and that was education. So, wage equals to alpha plus beta 1 di plus beta 2, let us say education I plus ui. Okay. Now, when we have education variable, that means one quantitative variable involved in the model, the interpretation of alpha is not basically the mean salary of the base category, because you have education also involved. So, in that case, what would be the interpretation? You can say that alpha is basically the intercept. Alpha is intercept, and what is beta 1 in this case? And in this case, so beta 1 would be again the differential intercept. Okay, differential intercept. So, that means in this model, quickly if you take expectation given di equals to 1. So, this would become alpha plus beta 1, alpha plus beta 1 plus beta 2 education, and if you take expectation of wage I given di equals to 0. So, you will get alpha plus beta 2 education. So, that means here for the female category intercept is alpha, for the male category it is alpha plus beta 1, this is for male and this is for female. So, for female the intercept is alpha and for male it is alpha plus beta 1. So, you can quickly say that beta 1 indicates the differential intercept. Okay, differential intercept. And how will you interpret in terms of what would be the practical interpretation? You can say that for every level of education, that means male workers they earn beta 1 amount higher wage than their female counterpart. So, this particular the second case, if you represent in terms of a diagram, here it is wage and here it is education. So, let us say this is my male and this is female. Okay, this is male and this is female. So, this is male's intercept is how much? Alpha plus beta 1, and this is simply alpha for the female. So, beta 1 is basically the differential intercept. So, that means you can easily understand so that means this difference is basically the beta 1. So, for every level of education, male workers they earn beta 1 amount higher wage than their male counterpart. Okay, and the slope is same. So, that means these are the two parallel lines. That is why the difference at every point it is only beta 1. For each and every level of education, the male workers they earn beta 1 amount higher wage than their female counterpart. That is why we say that beta 1 is the differential intercept, and the practical interpretation is male workers on an average earn beta 1 amount higher wage than their female counterpart. This was our second case. And in the third case, in this case, what is the implicit assumption we said, if you recall? Since the slope is same, that means responsiveness of wage with respect to education is same for the male and the female workers. That means if the male worker goes for 1 extra years of education, then the increment what the worker will experience in their wage is same as if the female workers also go for 1 extra year of education. Okay? So, that means both male and female workers, they will enjoy beta 2 amount of increment in their wage if they go for 1 extra years of education, since both male and female workers wage function have the same slope as beta 2. Beta 2 is the slope, that is the assumption. If we relax this assumption, then we will get our third case. So, our third case was wage I equals to alpha plus beta 1 di plus beta 2 education, and we have one third variable also where we are interacting di with education. Okay, education plus EY. Okay. So, in this case what we said that if you quickly take again expectation of wage given di equals to 1, what will happen? This would become alpha plus beta 1 plus beta 2 plus beta 3 education. All right. And if you take expectation of wage given di equals to 0, what you will get? You will get alpha plus beta 2 education, and that means this is male and this is for female. Okay. So, that means from this what we can say that beta 1 still indicates differential intercept, but here beta 3 indicates differential slope as well. So, that means for 1 extra years of schooling or 1 extra years of education, while the male workers enjoy beta 2 plus beta 3 amount of increment, female workers they enjoy only beta 2 amount. Okay, because the slope of the female workers is only beta 2. So, that means in terms of a diagram, if you represent this is education and this is wage. So, let us say this is the male categories wage function where the slope is alpha plus beta 1, and female workers wage is alpha and slope is beta 2. Assuming alpha is positive, beta 2, beta 3 all the coefficients are positive. So, what will happen? This would become like this. This is female. So, this intercept is only alpha, and the slope for the male is beta 2 plus beta 3, while the slope for the female is only beta 2. Okay, beta 2. So, from this diagram we can easily understand that for extra years of education, male workers enjoy beta 3 amount of extra increment. Okay. While both male and female they will enjoy increment, male workers increment is beta 3 amount higher than the female counterpart. Because how do you derive beta 3? As I said, the interpretation is derived, it is basically beta 2 plus beta 3 minus beta 2, okay, beta 2. So, these are the three cases we have discussed yesterday in our previous class, right. Now, what we will do? We will discuss about the fourth case, where in the fourth case, this is the fourth case. What we will do? We will introduce one more qualitative variable apart from the gender, let us say that is caste, okay. So, that means our wage function is wage equals to alpha plus beta 1, let us say this is d1i plus beta 2 d2i plus beta 3 education I am denoting by x1i plus beta 4 I am interacting these two, that means d1i multiplied by d2i plus ui, and once again I assume that increment is same, that is why I am not interacting the x with d1 or d2, okay. There is no interaction between d1 and d2 with the quantitative variable, that is again for the simplicity sake, right. How we have defined d1i and d2i? d1i as usual equals to 1 if male and 0 if female, and d2i equals to 1 if upper caste and 0 if lower caste. We assume that there are only two castes available, which is upper caste and lower caste, and two categories for the gender also, male and female, okay. That means here why we have introduced this type of model? We have introduced this type of model because our assumption is that the gender discrimination for the upper caste is significantly different from the gender discrimination for the lower caste. And what is the rationale for this? Maybe we are hypothesizing that the male female difference in their wage is little lower for the upper caste, because in upper caste maybe female workers, because of their empowerment or higher bargaining power, they could reduce the gap between the male and female labor force. While for the lower caste, female in the lower caste, because of their lower empowerment or lower level of bargaining power, they are not able to do so. That is why we assume that male female gap, the gender gap for the upper caste is significantly lower than the gender gap that prevails in the lower caste. That is our hypothesis, may or may not be true, okay, may or may not be true, that we have to estimate using a data and look at their significance and sign. Okay. So, now what we will do to derive the interpretation of beta 4. So, that means beta 1, what we can say that beta 1 indicate beta 1 indicates difference in wage for being male. Okay? Difference in wage, difference in wage for being male. And what is beta 2? Beta 2 indicates difference in wage for being upper caste. Then what is beta 3? Beta 3 indicates difference in wage for being upper caste male. Upper caste male. Okay. And we are going to, sorry, this is not beta 3, this is beta 4. This is beta 4. And beta 3 is basically the responsiveness of wage with respect to education, because X1I is education, education measured by years of schooling. Okay. Now what we will do? We will nicely derive the interpretation of beta 4, and this is very, very important case. So please concentrate and think about this case carefully. So what I will do? I will put here let us say upper caste, this is lower caste, then here it is male, and here it is female. Okay. So that means I will get several cases. Okay. So what we will do? For upper caste and male, what would be the mean salary? That means you have to take expectation of wage I, given D1I equals to 1, because male is defined as that, and upper caste, for getting upper caste you have to get D2I also equals to 1. And if you do so, then what you will get in this column, in this cell, for upper caste male you will get. So that means, let me okay, I will get several cases. So you have to put D1I equals to 1, D2I equals to 1. So you will get alpha plus beta 1 plus beta 2, okay, beta 2, and here also you are putting 1 and 1. So plus beta 4 plus beta 3 xi or x1i. Okay. This is the average salary or wage for the upper caste male. So the same thing I will write here, alpha plus beta 1 plus beta 2 plus beta 4 plus beta 3 x1i. Similarly, for the female category, what will happen? expectation of wage given D1i equals to 0, but D2i is still 1 because I am considering upper caste female, what will happen? So, this would become alpha, then beta 1 will vanish, beta 2 would be there, beta 2 would be there, plus beta 3 xi x1i, and here also since I am putting D1i equals to 0, the beta 4 will also vanish. So, this will become alpha plus beta 2 plus beta 3 x1i, right. Okay. Then for the male and lower caste, what will happen? This category, this particular case, expectation of wage given D1i equals to 1 because it is still male, but D2i equals to 0 because I am considering lower caste. So, that means this would become alpha plus beta 1 would be there, but beta 2 will vanish. So, beta 1 would be there because D1i equals to 1, alpha plus beta 1, D2i is 0 means beta 2 will vanish, plus beta 3 xi x1i, and this will also vanish if I put D2i equals to 0. Okay. So, that means this column for male lower caste, this would become alpha plus beta 1 plus beta 3 x1i. Okay. And for female and lower caste, that means expectation of wage when D1i equals to 0 and D2i is also 0, that would become alpha plus beta 1 will vanish, beta 2 will vanish, then I will get alpha plus beta 3 x1i, and beta 4 will also vanish because I will put D1i, D2 both equals to 0. So, this would become alpha plus beta 3 x1i, okay, x1i. Now, when I am putting D1i equals to 0, D2i also equals to 0, that means, please keep one thing in mind clearly, when you have two dummies, two qualitative variable, what is your base category or benchmark category? To identify the base category or benchmark category, you have to assign 0 for both the dummies. So, that means when I am putting D1i equals to 0, D2i is also equals to 0, that is now becoming my base category. So, what is my base category then? Female lower caste. So, lower caste female is my base category. Okay. So, now what I will do, since my objective is to get the gender difference in upper and lower caste. So, this I will get as male minus female. Okay, male minus female for the upper caste. So, from this minus this if you do, what will happen? Alpha will cancel, beta will cancel, beta 2 and beta 2 will get cancelled out. So, I will get this minus this equals to alpha plus beta 2 will vanish, alpha plus beta 2. So, you will have beta 1 plus beta 4 plus beta 3, sorry, beta 3 will also get cancelled out. Okay, this minus this. So, I will get alpha plus beta 4. For lower caste, if I take male female gender difference, then alpha will get cancelled and beta 3 x1 I will get cancelled, I will get beta 1. Now, if I take the gender difference of upper caste and gender difference of lower caste, then what I will get? This minus this equals to beta 4. Please try to understand. Beta 1 plus beta 4 indicates the gender difference, because this is male minus female for the upper caste. Beta 1 indicates gender difference for the lower caste. If I take these difference in difference, that would become my beta 4. And what is the interpretation of this? The interpretation is beta 4 indicates what is the difference in gender gap between upper caste and lower caste. For both upper caste and lower caste, we assume there is a difference in gap between male and female, but we are trying to hypothesize whether the gap, gender gap, is significantly different for the upper caste compared to their lower caste counterpart. Okay. You may get another interpretation of beta 4. So, that means here basically beta 4 is difference in difference, because we already got one difference here. This is male minus female, this is also male minus female, again I am taking difference. So, that is why this is called difference in difference, difference in difference estimate, which is a very, very important, interesting and powerful tool in econometrics. You have to carefully understand this difference in difference estimate, or in short DID. Similarly, if you want to understand the caste difference between male and female, so we hypothesize there is a caste difference for male, there is a caste difference for female, then we can test whether the caste difference is significantly higher for male than their female counterpart. So, this is because your upper minus lower. So, if you take difference for upper and lower for the male, what will happen? Alpha and alpha will get cancelled, beta will get cancelled, beta 3 will get cancelled. So, you will get beta 2 plus beta 4. So, this is beta 2 plus beta 4. Similarly, if you take the caste difference for the female category, this minus this, alpha will get cancelled, beta 3 will get cancelled, then you will get beta 2. And then if you take again the difference in difference, this also, so that means column wise if you take difference, still you will get beta 4. So, that means here beta 4 basically gives you two types of interpretations. What is the two types of what are the two types of interpretation? So, the first interpretation of beta 4 is basically if you take row wise difference, then that gives you what is the row wise interpretation, because I have taken male minus female, which is basically the gender gap. So, gender gap for the upper caste and gender gap for the lower caste, and then again I am taking difference. So, that means I am trying to understand difference in gender gap for the male and female category. Difference in gender gap. We are hypothesizing that gender gap is for the upper caste is quite different from the gender gap the lower caste. Okay? That is one interpretation. Okay? And what is the second interpretation I said? That caste difference for the male, caste difference for the female, and then you are taking again difference. So, difference in caste. So, difference in caste difference. So, caste gap between male and female. These are the two ways by which you can actually interpret the beta 4 coefficient, and this is known as difference in difference estimate. Difference in difference estimate. This is very, very powerful. This is very, very powerful in policy evaluation kind of studies. Policy evaluation kind of studies. So, what I'll do, I will give you another example of this case to show how this difference in difference estimate can actually be used for impact evaluation or impact of policy evaluation. This is called impact evaluation.